Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. Today we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi class, lesson number 6. This week we're doing a simple GPIO input from a push button and output to an LED. Before we begin, I want to talk a little bit about the push button I'm using because typically inside of a kit, you can't even see this on camera, these tiny little tact switches. They're very difficult to use because they usually have short pins. Yeah, you really can't see this very well. Short pins, and they usually look kind of squarish. So you have to decide which way on the breadboard are they going to go, and you have to get it right. So when I'm doing anything with tact switches, I like to use the larger ones. I have a set of larger tact switches here. Let me see if I can get this into camera view here a little better. These larger tact switches, longer leads, and they have a much more rectangular shape, so it's clear which way on the breadboard they go. And I don't know if you can hear it, they have a gratifying click sound that the smaller switches don't. So let's get into our project and let's take a look at what we've got going on here. So I had seen a comment in the chat last week. Somebody was talking about they were disappointed that they had to take apart their old project from last week's lesson to build the new one. And I decided I'm going to try to leave as many projects on the board as I can so I don't have to disassemble them. I can still sit and tweak the code. So you can see I've still got the LEDs from lesson 5 when we did the binary counter. And this week I've just added the 2 push buttons. I'm actually going to leverage these as my output device for this week. So I decided to do 2 push buttons, and the reason is because I wanted to highlight the difference between a pull-up resistor and a pull-down resistor. So you can see with the pull-up, I'm taking voltage off of the positive rail, and you can see that this is a 3.3 rail. So I have 2 voltages on this breadboard. I have my 5-volt rail back here. I have my 3.3 volt rail here. Don't fry the Pi. We want to make sure we know which voltage we're using because the Arduino will take 5 volts in. The Pi will not be so lucky. So what I've done is taken a 10K resistor to run from the plus 3.3 into my toggle, into my button switch. And then the other side I've just shunted to ground with a short jumper. So when I close the circuit here, well, actually, when I read the input from this pin, it's going to show high or positive or true or 1. And when I close the switch, it's going to bring that to ground to make it low, false, 0, however you want to read that. A pull down resistor, on the other hand, is the opposite. So right now I have a 10K resistor to the ground rail, which means that the input pin is now reading 0 or false or low. And when I close it, I'm moving the 3.3 volts into the input pin, so it's going to read high or true or 1. These are both kind of common practices. I prefer the pull up resistor because I don't like the fact that I'm sending 3.3 directly into an input pin. I'd rather have the safety of the 10K resistor when I'm putting voltage to an input pin, but it's legitimately working in both cases. So now let's do a quick change over here. I'm going to launch the program and we'll start seeing it in action. So I'm going to hit this one to light up those 2, this one to hide up those 2, and you can see I just go back and forth. Try to move my fingers so you can see the LEDs better. You kind of see going back and forth. And then what happens if I push them at the same time? Oh, look at that. We exited gracefully when I pressed them at the same time. That's because there's a few ways to gracefully exit the program and release the pin configuration, but I wanted to do it in a more graceful manner where I didn't have to use the keyboard. So with that, let's jump into the code. If it lets me, there we go. So I'm going to start at the top where we should start. So I'm bringing in our Pi GPIO as not the metaverse. This is just to demonstrate that we can use something different than GPIO. By the way, I don't recommend that because as you see when we go through the code, using a long string like not the metaverse gets a little painful. I've got my LED output pins, the same ones I used last week. I've tied the pull up button to GPIO 18, the pull down button to GPIO 16. And now I'm going to go through, and of course I'm using board numbering. I'm going to set my pins. So I run through the same output procedure that I ran last week. And now I'm going to bring these in as input. And I'm going to do these both as input, but I'm going to use this one. I'm going to specify it as a pull up. And this one I'm going to specify as pull down. So once I have all my pins initialized, I'm just going to print something to the screen just to show that the program is in fact running. And then I'm going to head into my while loop. And we're just going to do a really simple, if the pull up button is false, so if it's pulled up, that means by default it's true. So if I push the button down, it will be false. So if the pull up button is pressed down, we're going to light number 3 and 4, which is these two high bits right here on my LED display. And then obviously, if it's true, we're going to dim them or set them to false. Then we go the opposite way with the pull down because it's always in a state of 0. So if I press it, it goes to a state of 1 or true. So you can see the difference here. If I'm using a pull up, my state change is false. If I'm using a pull down, my state change is true to get the desired result. And then I have an if statement of if both buttons are pressed down, so if the pull up is false and the pull down is true, that means we're going to exit. So I print out a statement saying, hey, we're going to exit. I light up all the LEDs. I pause for 1 second just so we can see the LEDs fully lit. You can read the message. Then we turn everything off, we clean up, and we exit. And that is how I addressed this week's homework. Maybe a little extra steps, but I enjoy it. This week's homework is a little bit late, and I want to point out why. I was actually waiting for the Amazon truck. Last week in our lesson 5, I had to use what jumpers I had on hand for male, female, which are these longer ones. I put a loop in there just to make them a little tidier. And as you can see, I now have these nice short jumpers that are going to be a lot neater and cleaner going forward. So that's why my homework's a little late this week. Thanks for watching, and I'll see you next time.